So, welcome to another episode of BetaTalk. I'd like to thank my season sponsor, which is Primary Pro. Primary Pro is a outside pipe insulation system invented by my friend Dave, and lots and lots of the good engineers I know are using it. It's a great product. That's Primary Pro. So, today's episode, I'm joined by a regular guest. You all know him, Barry Sharp, but we've actually got the best Sharp that I know. We've got Barry's dad.
You can't help yourself but get to dig in somewhere. It's always something.
Thank,
we got we
thank
got
you for
Dun-
that, Nathan.
we got Duncan joining us. So Duncan's not been on the show previously, but obviously Duncan and I have had quite a few drinks together when I've been up Scotland, or he's been down this way. And today we're going to talk about MVHR because that's kind of where Barry has sort of also where Duncan has set up a niche for himself. He's been in the game a long time. Obviously, Barry sort of started his sort of plumbing and heating career back in the day with Duncan, and Duncan, funny enough, was around in the conversion days. So we'll probably dip into a bit of the history because obviously we're in a bit of a transition now. But Duncan has arguably been already through a transition. He started his apprenticeship in '73, and that's when Scotland were in full swing of converting from tower gas to natural gas, methane. So welcome to the show, Duncan. So you've been involved in this MVHR. So how long have you been doing that, and why did you get into it?
About 14 years, to be honest. I actually fell into it. I had a good friend who worked for New Air down in Caerphilly. He gave me a phone and said, "Are you interested in doing a bit repair work for us?" I says, "What on?" He says, "Ventilation." I thought, okay, yeah. So he directed me to a site in East Lothian, which had just been completed social housing. And I didn't know the first thing about it, but I was there to do a survey for him. So I did the survey and said, I need to learn more about this if I'm going to do any work for it. Yeah, okay. Went down to Caerphilly, got trained up, and I've been doing repairs and replacement and new installations since then. So 14 years I've been doing it.
I'm laughing at that because that's exactly how we got into heat pumps. Someone said, "Do you want to do a heat pump?" We didn't know what we're doing then either. That was 20 years ago.
So you said you're training, Duncan. Did you? Was it the manufacturer that trained you, or was there any course available
No,
at the time?
it was a manufacturer, but it was at the time, it was a BPEC certificate, right? And it was a BPEC certificate. You went down and you learned on their product, New Year's product in Cardiff. And you sat an exam and you sat a practical exam on it. And you had to get a 90% pass at the time. And it was a BPEC certificate. And that basically gives you an insight to the ventilation, not just MVHR, but mechanical extract and DMEV, direct mechanical extract. So fans, wall fans, and then house fans. So I did a bit of everything on it. But in Scotland at the time, 14 years ago, there was a lot of social housing being built. And the Scottish government decided that as a energy saving system, they would take away the trickle vents in windows. They wouldn't put double glazing windows with no trickle vents. So if they did that, they then had to fit mechanical ventilation to give the house adequate ventilation. So that was great. We picked up on the faults on them. Basically, you talk about heat pumps not being installed properly. It's the same system here. You don't install it properly, you don't commission it properly, it doesn't work properly. And we get mold growing, we get dampness in the system, we get water penetration from extracting moisture from the air. It can run. If it's not installed properly, it will not work properly. So MVHR, I think this is a product that came from the passive house systems, from the oil embargo, right? We were looking for energy savings in people's houses. This is what MVHR came from. And it was quite a bulky start to it, a big piece of equipment, which basically extracted from kitchen, bathroom, toilet areas, put it through a heat exchanger, drew air from outside across the heat exchanger and delivered fresh, warmed air into the bedrooms and living rooms. But if you didn't have it installed properly or pipe sized properly, it didn't work. It became an issue. People turned them off because they say, oh, I'm getting cold air coming through here, and turning it off. Without trickle ventilation in people's windows, you're going to get dampness. You get mold growing. So we inherited a lot of problems on sites throughout Scotland with issues with dampness on it.
What's the main problem you're seeing?
The main problem is not installed properly and not commissioned properly.
What symptoms are you seeing then? When you go to the house, what are you seeing?
Well, we go to the house, we see black mold in the kitchens and bathrooms, and I mean black mold, huge amount of black mold. And that's a health problem. We're going up there and we're seeing units that have not been serviced in 10 years.
And that's in social housing?
Absolutely.
So the bag's still on them.
Yeah. We've gone there and we've got to jobs, Nathan, and the filters are delivered on a unit and they're in plastic bags. The first thing you've got to do is take the plastic bag off and put the filter back in again. We're going to jobs and seeing that's not even done.
So a 10-year-old MVHR system with a filter still wrapped in polythene. So it's not done anything in 10 years.
Who's doing the work? Is it like a social housing would have their contractors on frameworks, wouldn't they? And
absolutely. So we built houses on a plan because we were short of housing in Scotland. We're short of social housing. So we're building these and we're putting, the architects are saying you put MVHR in, we're not putting trickle vents in. So yeah, you give that to an engineer. So who does it? Does the plumber do it? No, he doesn't want to do it. So you say, the electrician, can you do this? Yeah, we can do that. And they go in and they put the wrong size of pipe in. They put the wrong type of pipe in.
It's like cut and paste from heat pumps, isn't it?
Yeah, and they go in and then they put it all in and there's ceiling vents in it. You have to balance the system. You have to extract a rate by building regulations, and you have to match that extract with input so the house is balanced. They don't do it. You have proper tools for it. You have a flow meter for it. We've got, each one of my guys has got a flow meter, and that's a 450 pound piece of equipment that will tell me exactly how much it is extracting from a ventilation system and how much it's putting back in again.
So you ever seen them? You ever see anything balanced or set up properly?
Yeah, I'm hitting with a big wide brush there saying, yeah, they're not numbers. Some of them are. Some guys have done great jobs in it. We're getting more and more guys being specialists at this. Right, and they are the guys that leading the way and showing us how to do it. Same as heat pumps, but we've still got people thinking that they know what to do. It's just ventilation. It doesn't matter. It's not just ventilation. It's important for people's health. It's important for air quality. If we've got this, we're now looking at changing them out, Nathan, 14-year-old ones. We're changing them out because there's so much mold in it that if I go and service it, I move that mold.
So that'll be a health risk to you then, isn't it?
Absolutely. The guys have got white masks, they've got gloves and everything we go to do it. We'll open the front cover, and if there's mold growing, we'll shut the front cover, turn it off, and tell the people we need to change it.
it's a bit of a, because obviously on social media, a lot of people talk about MVHR now, and bless them, they don't actually know a lot about it. They've never put systems in, commissioned them, etc., etc. And it gets sort of bandied about as this great thing that's great for retrofit. Well, it's very, very hard to put in. I mean, it's hard enough to put it in new builds, but the irony is it's supposed to be making your environment nice, healthy, clean, and yet ironically it's completely doing the opposite in a lot of cases, isn't it? Absolutely. We can see it. My guys see it on a daily basis, right? And we're trying to educate, still trying to educate, and I'll go and we'll look at jobs and you'll say, well, that's not suitable for the house. We now have air quality meters. Each guy's got an air quality meter and he's got a dampness meter. He's got his flow meter. We can go in and tell you how damp the house is.
What are you measuring with air quality? What are you looking for?
We're looking for the parts per million on carbons. We're looking for CFCs. We're looking for anything that'll give us it. A lot of housing now are stipulating new build that there's an air quality meter installed in the house.
Oh, wow.
Yeah, we've seen that in bedrooms. You see carbon dioxide measurements in bedrooms now.
And it's got a traffic light system on it, and it'll tell you, we get a phone call saying my traffic light, my thing's red. And says, that first thing in the morning? Yeah. You need to open a window straight away, and then you come back an hour later and see if it's gone down any.
Is this more of an education piece for people, house owners, rather than anything else? I don't think. Why is my room feel stuffy?
why have I got a headache? Because there's not.
You've not left the house for 4 days.
there's not anything in it. But we've got standards that are already issued out in building services. We know what the standards are, and we know how bad it can get on it. People are not paying attention. They're not waking up to this. Right? We're building houses and we're making them airtight now. Airtight and solid. Right.
So this is a knock-on effect of making houses super insulated, because we're vapor barrier them as well. Absolutely.
Now. Vapor barrier, and we're making this hard. So we're containing the vapor inside the house. So you're told not to open windows and doors because your heat's going out. You have to do something about it, or your air quality is going to get worse and worse. Dampness is going to start setting in, and it's a very difficult thing to move, dampness. And mold is very difficult to move as well. There's so many products on the supermarket shelves that are actually dangerous to your own health. If you're using it.
Cleansers and cleaners and
cleaners, stuff like that. You can buy them on the internet, and they're really powerful.
I can see Barry. I can see Barry in his bath with scented candles. Do you think we're obviously talking about social housing at the moment. I mean, do the occupants in social housing have these systems explained to them well enough so that they're using them properly?
No, definitely not. Definitely not. I'll give you an example of that, Nathan. The Commonwealth Games was in Glasgow 15 years ago, and we were on site regular on that, repairing and replacing bits and pieces on that. And we were going to the sites after the Commonwealth Games was finished, and the social housing took over. They took over 75% of the housing that was there. The other 25% was sold privately. So we go in there, and you say, why haven't you put your ventilation on? No, I don't use it, son. Well, why don't you use it? It's costing me £20 a month. No, this is not costing me £20 a month. No, it is. I got told it was costing me £20 a month. I says, it's got 2 7-watt motors in it, right? It running at full belt, it'll not cost you £20 a year. But they got the story. So we had whole streets turned them off. Right? We went back to
they can't see the benefit. They can't see the benefit and the cost.
No.
Even at 20 quid, if it was keeping their house healthy, they wouldn't pay it.
Yeah, that's the difference. Is you can't tell them you need to open windows. Don't tell me how to open windows. I can't afford to heat my house. But we did this, and we went to the housing association, and we discussed that with them. We said we need to get these serviced every year to make them efficient. We can start cutting the noise out of them if we get them working properly. We'll start balancing them, and we know if the customers turned them off. We can tell you if they've turned them off, because we can tell the filters how dirty the filters are. So one of the forward-thinking housing associations in Glasgow, west of Scotland, they took us on board, and every year we go around and service 250 of these units, and we clean them with filters. We've cut the breakdowns out of them by probably about 50%, because we're real regular, and the customers are starting to use them. And they say, when it breaks down, the call is in, I missed it, because it was really, I could feel the difference in air quality in it. So we know that if we take time, we can educate them.
Oh, that's interesting. So it is 100% education then. So once you show them the benefits of it, they buy into it.
Yeah, they do buy into it, because we can calculate how much power they're using. It's only two 7-watt motors that are running it to do the whole house, right? And the newer ones are coming out that can go slower as long as the air quality monitor's fine. They've got air quality sensors in them now. The new ones are coming out, so they don't touch them. They know that they can slow down. They have peak times on them when people are in for their meals. They can sense that, and they can speed up accordingly. So they are now registering the quality of the air coming back into the system and adjusting the rate to suit them.
Because if it had a set rate all the time, you're actually only needing the full rate when the stuff happens. You've got background noise anyway. That's
yep. It's supposed to be, if you fit them up, Nathan, and you've got the older systems, you would set the bathroom at 10 litres per second on boost, in the kitchen at 14 litres per second at boost. And if you had a WC in the house or a shower room, you set that at 8 litres per second. So you add them up, that's your maximum extract. So your maximum input should be identical. But when it's not in boost mode, it can go down to 75% of your boost mode and it quietens down. It still does the same effect on it. But they're linked together, the two motors, so they should both spin at the same and take the same volume out. That's the issue of getting right, is basically balancing it. People are now understanding it a bit more.
I was going to say, the people living in these social houses, if they are living in homes that have got very good working systems, can they actually feel the benefit of it and they actually like it, do they?
Absolutely. We've now educated them, because we're now doing it every year in some of these places. And they're saying, yeah, I know when it's off now. I know when it's gone off, because I can feel it in the air. And go, well, that's what it's for. And you get a lot of people, yeah, but if we're not on the ball and we're not going the next day, they'll phone us up and say, when are you coming? Because I can tell you that it's not working properly. All right, we'll be out tomorrow, Wednesday. But we have various new sites now, 2-year-old sites we're going to, that never been touched. And we're going to them first time. And we're hopefully they'll go back and they'll say, this is part of our programme. But like everything else, they won't service these things when they should service them.
Mm.
Do you think there's a place for MVHR in existing housing stock?
Yes, I do. I do believe that. I'm involved in one or two of the retrofit forums that are going about in Scotland at the moment. And we talk about this, and we talk about how best to ventilate a retrofit, because we're going to clad these buildings to make them more efficient. Right? We're going to clad them, and we're going to change the air in them. So we're going to have to ventilate them somehow. Right? And we've been working with some of the housing associations and that have got little projects going. And they come to me and they say, can we fit MVHR? I say, yes, you can. I can retrofit an MVHR.
It's not quite hard to do it retrospectively.
It is retrospectively quite hard, but most of this retrofit stuff in Scotland is flats. So if I can get a cupboard and I can get access to outside by dropping the ceiling in the kitchen or dropping the ceiling in the bathroom by 100 millimeters, I can fit full MVHR in the house.
Just in one room, drop the ceiling in one room?
Drop the ceiling. Basically, if it's one room or if you've got a cupboard going to the outside, you can pick up air.
Your centre point,
yeah,
just ventilate from the centre point. Then
we've done it. We've done it for bad condensation jobs for 2 or 3 that housing associations. They've come. Can we fit MVHR?
So is that they've done a deep retrofit and then they've come back and said, "Hang on, we've now got problems with ventilation."
Yeah,
jeez.
So
they'll be picking that up in a retrofit assessment.
Well, that's what I think. The retrofit assessments now, more and more of it. I worry because the retrofit assessments look at it so much stuff that probably isn't needed.
So you talk about past 2035 then?
Yeah, past 2035. We need to start slower. We're talking about cladding the building and changing the windows to triple glazing. We're talking about putting heat pumps on verandas. Guys, slow down. You're looking at German systems that are basically designed for new build, and we're trying to retrofit it. I said, keep it basic. Keep it basic.
So would you only fit it in a retrofit if you had air issues, not for energy? Is that what we're saying, or?
Well, if you're going to do energy, then you're going to clad it and you're going to put a heat pump in and what have you.
Part of the energy.
Part of the energy. So
it's almost like a knock-on effect of being energy efficient. It's not something you do to save energy.
It's not. We're going to reclaim energy because we're not going to throw it out the door. We're not going to put a fan in the kitchen and just blow the whole thing out. We're going to save it by bringing it through the system and getting a 95% heat exchanger on it. So what we take out, we're getting 95 of that back.
You're going to completely destroy the heat pump industry because nobody will know how to calculate that. We can't do air changes, never mind ventilation.
It's good, but the heat pump manufacturers are now, they're all on the same thing. They're all talking about MVHR.
You seen it at Ish a couple of years ago. Everything was doing these integrated systems where you just take a wall and it was about maybe 300 or 400 mil deep.
Yes.
And it had the hot water, underfloor heating, ventilation. It just
Yeah.
took a wall up. It's just like the back of a cupboard. Like Wiesmann and that had it. It was just like one just big, huge bit of plant stuck on a wall. Had everything on it.
Well, that's it. The one I was talking about, the German one I was talking about there is Blue Martin. And you cut the first course of brickwork and a double brick wall, and you fit this inside the brickwork. You put a heat exchanger in there, and you put an extract on it, 2 fans on an extract, and you've got an MVHR system that's slimline.
Before I forget, are you two going to Ish? Because it's this year, isn't it, Ish?
I've not asked my wife yet. I'm going to try and go home tonight and see if I can talk her into it.
Unless somebody's
it's only January. I'm running out of passes already. Are you going?
No one's invited me yet. I'll speak to Damon because I can't. I'm not going unless someone invites me. But I haven't got that much money. I'll speak to Damon the other day. I think he's going at with one of the.
It's something else. It's wild how
it
big
might be
is.
too big for me. Sometimes these things. I mean, installer's big. I mean, this is
no installer. The size of installer is one hall ish, and there's 9 or 10 or 11 halls.
Exactly. I mean, that to me. I mean, I find it hard enough to get around installer.
There's a whole football stadium full of toilets.
One of the questions I think people listening to this, Duncan, would be, how much? Because obviously it's heat recovery. So we're doing 2 things. We're ventilating the property, so we've got some nice, healthy, environments inside. How much heat recovery? Well, you said 95% there, but a lot of people sometimes I think MVHR is kind of like a secondary heating system, but that's not kind of what it's doing, is it?
No, it's not. It's not. We have a local authority, a housing association again. They didn't put any radiators in their upstairs bedrooms because they were told that the heat pump, the MVHR would do it. And I says, no, it doesn't. What it's extracting in heat from a kitchen and bathroom is wet areas. It's where you're normally heating it, and you're using steamy water to bring it. Will take 95% of the heat out of that, what it's extracting, and put it into the bedroom. So we will raise the temperature of the air coming from the outside to inside by 4 or 5 degrees.
So unless you've got a heat source, you'll eventually just work your way down to zero.
We have a passive house in one of the housing associations, and they got told this was going to work, and this was it. So they didn't put any heating in the house; they just put an MVHR in. So an MVHR is 95% efficient on the heat it's taken out of the bathroom, but that's 95. It goes down every cycle. So if you're not getting any heat and you're only putting 95% back in again, it's dropping the temperature in that house all the time.
What do you see typically on the thermometer? If you've got a thermostat on it, what do you pick up?
We get, it depends on outside air temperature, but we can see internal air temperature coming from 10 degrees to 14 degrees using the gun, the airflow meter.
So we get 4 degrees. That incoming air is sitting at 14 degrees. Yeah. So that would feel like a cooling effect to somebody in that room.
It would feel like a cooling effect, but then the benefit of air getting circulated is the whole house should be feeling the same thing.
That's all balance out.
It should balance itself out in it. But if they're in for a shower and it's running and all the steam is getting taken away, we're picking all that heat up. We're condensating the water inside the heat exchanger, into a drip tray, and out to the soil vent pipe. And we can get all that 95% of that heat we can get back in the house again.
95 sounds like a boiler manufacturer saying that.
You've got a condensate system. It's all part of this, isn't it? To get
it is. You need to get rid of the condensate. The condensate is it's not acidic. It's not like a boiler, but it holds all the bugs that's trapped in it. It holds everything. So you need to get that away. If you don't get it away, it sits in the unit, and all I'm doing is creating a moist, warm nesting paste,
dirty water
for bacteria to grow.
So that if that water pools somewhere or doesn't it drain properly, you've got. Yeah. Do you see that?
We see that when if you're fitting an MVHR, it should be semi-rigid or rigid ducting. It should not be corrugated ducting, and it should not be, we call it tumble dryer ducting. Right? It should not be that. any heat that's in that will evaporate through the walls of the pipework. If it's corrugated and it's not pulled taut, it will form valleys and water will sit in it. So you get a nice warm attic. You get summertime, you get all the mold coming, all the spores coming in through the ducting, getting sucked in through the air, and that's where the breed sat there. And
it's worth picking up on that point or re-emphasising that point, because as you all know, Duncan, a lot of the early stuff, I would argue, went in with the wrong type of pipework, and there seems to be people still using it. I mean, so yeah, just for the listeners, sort of try and describe the different types of pipework again that are getting used on these systems.
So we'll start with the good stuff. That's insulated ducting. It comes polystyrene. It's 125 millimeter internal diameter, and it's about 210 millimeter external. So you've got about a 25 millimeter insulation on it, right? It's made of polystyrene. It comes in meter lengths. It's easy to cut. It's easy to put together. It's got sockets and elbows, 95s,
and it's rigid.
You want in fitness wise. Rigid. That's rigid. That's what we use in any lofts. We use that. We use it rigid ducting in any loft or any cold area. That's right up to the roof.
It's just the same conversations we have at microbore or 28 mil.
Yeah. So it's 125. You can use bigger if you've got a bigger volume. You can go up to 200, and you can do the same thing. Then you get pipework, semi-rigid. It's like corrugated ducting. So it's 75 millimeters or 90 millimeters, depending on what size you need for volume. You can get that, and that's got an air barrier in it. So it's got air, so it's got insulation inside it. So you don't need to insulate that. Then you come on to the plastic ducting. You can use plastic ducting internally. You can't use it in an attic space or a cold area, because that'll condensate anything that goes inside it. You get it in 125 is normal for MVHR, but you also get the 100 version, 100 millimeters, which is a fan size. If you put a kitchen fan in, it's 100 millimeters or 125 millimeters. But if you're going through a wall, you don't need to insulate it because you're going straight out with it, short distances. Then you get flexible ducting. You get flexible ducting that's insulated. It's covered internally, it's 125. Externally, it's got a cover around it, and it's insulated with fibre wool or whatever they've got in it. That you can use that, you need to pull it tight. You don't put a bend in it, you pull it tight. And then you get tumble dryer hose, which everybody knows. It's the one that they can say the kits for kitchens. That's a waste of time. That's thin. It buckles. It makes valleys in it, and nobody actually does it. You'll see sometimes on LinkedIn. There's a few guys show pictures, horror pictures, and I'm disgusted. But that's the way people fit them because it makes it easy.
You said with the insulated type, to pull it tight. And I think the trouble is because it's flexible, people think it's supposed to be, you use it as flex, and you can, go up here, around here, and all this, and U-bends. It's a bit like shower pumps. Shower pumps have flexible hoses, but they're not designed to be flexible. They're anti-vibration hoses, so that you're not getting vibrations through your rigid copper pipe. But people will bend them 90 degrees. I mean, they're only supposed to be bent, I think, maximum 15 degrees. Yeah, but people have always, loads of plumbers I know, will think they're a flexible hose to get you out of a problem, to attach it on. But they're not. They're anti-vibration pipe. And it's a similar thing here. Is that you got to keep that stuff quite as straight as possible. You can deviate a direction, kind of, but it's. You're not supposed to be putting U-bends in S-bends and all this sort of stuff.
If you've got your qualification, which is domestic ventilation systems approved document F, it'll tell you in there that you're only allowed to have 300 millimeters per linear meter of ducting flexible. Right. So if you're going along and you need to kink it a little bit, it can only be 300 millimeters per linear meter of ducting on that leg. Or on that line. So you get that point where you can make it go into the top of a valve or what have you. But it's only supposed to be 300 millimeters, and it's supposed to be pulled tight at 300 millimeters. So we're not outlawing it. It's there for a purpose, as you described there. We need to use it to change direction to get in the tight corner. So we try not to use it if we can get away with it.
What about sizing systems, Duncan? Yeah, explain to the listener, how do you size a system? What are the things you're looking for? Is it all down to like square meterage of a property? What sort of things you're looking for?
It is actually down to that. We know that we need to get a demand extract in the kitchen, bathroom, WCs. We know that. So we've got to calculate that we've got to take 14 litres per second out of a kitchen on boost. So we need a pipe big enough to take 14 litres per second on it. Right? We know that we can, if it's short runs, we can get away with possibly a 90 millimetre ducting or two 75 millimetre ductings, semi-rigid. But we will calculate the volume, the length of pipe, the number of bends. Right? It's the same as a pipe sizing. Same formula uses a pipe sizing. So taking the volume through it.
Do you do it internally, or do you ship it out to someone else?
We do. Normally, if somebody came to me in a new build and wanted an MVHR system, and I would ship it out to the manufacturer, and he'll do a design for me, right? But then, if I'm doing a retrofit, I will know what I need to pull from each of the rooms, and I know what size of pipe I need to do.
Are you
some experience in?
Yeah.
Are you happy with manufacturers doing design? Because obviously, in the rest of the heating world, sometimes that can go wrong. Underfloor heat. I'm not being horrible to underfloor heating, but people, by the way, but sometimes their designs are, and same with boilers. But boiler manufacturers have been involved in design, and So I mean, I suppose that comes to another point. Are there manufacturers that are better than others? You've got to be careful.
Each manufacturer has their own range and their own target market. Right. We get the guys that are coming in from the continent who have been doing ventilation a lot longer than we have, with better systems on board, smaller size ducting, better fans on it, but they're used to a European market for it. Right. It's accepted. And in the UK, we build houses and then we think about ventilation afterwards. So you give a set of drawings to a manufacturer, he will come with his product, his pipework, and his valves. Right. So, and if you don't follow it, they won't warranty it for you.
We've got this problem coming because we do the odd bit of MVHR if it comes as part of a package, but my lead engineer loses his mind with it because no architect thinks about it. It's very rarely thought about it. So the time you on site, it's too late to think about routes. It's like maybe years ago, Nathan, you maybe get asked to do a plumbing system and there's steel everywhere and you can't get 4-inch anywhere. It's the same thing, but we multiply it by 10 because there's 10 ducts going everywhere rather than just one pipe. Mm. And really, the experience I've had, the systems we've done, it has to be designed in at architect stage, not as an afterthought. Because you have to have roots for everything. And space for it. Space for the big, if it's a bigger house, you need space for all the pipes to come together in the actual unit.
I'd have thought some architects would have been right into this because it's a bit of a USP, a selling point for the actual architect. Yeah, but
if they've never done it before, they've not really thought about what's involved.
Yeah.
It's I had a bit of a wake up call. I don't know if I said this to you. In West Lothian, where we are, an architect said to me that's them looking to put MVHR, the building control looking for MVHR in every new build now. I was like, oh, here we go.
Yeah, again, if you get good drawings from an architect and give it to the manufacturer, he will know where the steel is. We know you can't go through steel, right? So we can find other routes to do it. Yeah, we've all got a way we can get around it. There's not something that I've not been able to get around. Somebody's put steel in a new building, it because it's experience as well. See, well, we can come from a different direction on this.
That's where we fall down.
Well, you're used to large diameter pipes, Barry, Duncan, because you're older than Barry and I, and you were back in the early days when they were using large pipes.
Yeah, I think that's right. I think we still have the same principles on, and we did pipe sizing way back when we did gas to different parts of a house once. So we still had to do gas pipe sizing. We didn't have a calculator to do it. We did it by hand. We did it. So we need to get that rate there. We need that gas there. So
it's a good time to segue because I'm sure it was a SNP meet or something. Doug's going to be the president this year. SNP.
Yeah, I know.
Big medal.
I could send you an invite if you want to come up, Nathan.
I'm always up for coming up. Up Scotland. Well, that again, Scotland is a good segue because Scotland's got some great history with our industry, as you know. I mean, it's where Sir Dennis Rook, who was the chairman of the British Gas Boards back in the day. Everyone talks about this transition that we're in, and I've heard
Well,
Matthew Aylett talk about the transition and the gas one, converting from town gas
Dunk
to
was
heat.
at Dunk was at a meeting with me, and he kind of I spat my coffee across the table when he said this, because he said this is his third energy transition. I assumed he was going from like wood to coal to gas, but
it's actually my fourth one. And
fourth.
It's my fourth transition, because I'm going to tell you.
Hang on, Iron Age, Stone Age.
Yeah, 73 to 1980, Towns Gas.
Yeah.
Right. So I
Go and explain it, Towns Gas is for us young team.
Towns Gas.
They're in their 40s.
It was gas that was kept in these massive big holders. It was manufactured by heating coke and getting the gas extracted from coke. But in later life, we started mixing it with natural gas. Gas that we could make a calorific value match Towns Gas by producing it, mixing it properly, like a good blended whiskey. You can make a good Towns Gas, but each town had it. Now, just recently, Nathan, I was across in the west coast of Scotland and at Inverary Jail. Okay, so it's a historic site or a jail in a small village on the west coast of Scotland. And I'm looking at this, and they've got these pipes coming down the wall. And I went, "That's a gas pipe." The guy goes, "Yeah, we had gas here." "When did you have gas here?" "We had gas here in 1873. And the gas started, and they still had the pipes there painted black." I said, "What was the gas for?" "It was for heating the place and cooking on it." I thought, Christ, I wasn't at the conversion then, but I was in Towns Gas to natural gas. And then from natural gas, we were doing cookers and fires, and occasionally a big cast iron boiler. And I converted them because nobody else knew what they were doing, but the ideal standard boilers, massive E-type boilers. We converted them. So from 80 to 89, we were still doing gas cookers and starting to get into central heating. So Towns Gas to central heating, that's my first one, Towns Gas to central heating. Then we went from 89 to 08, I think, we're changing it to boilers, system boilers. And the combi just came along. And the first combi we ever seen in British Gas, it was then, was a Valiant. It was the size of a small wardrobe.
Mm-hmm.
It had a cylinder underneath it with a boiler on top of it. And we looked at these things, and that'll never catch. That'll never come on. No, but we've got boilers the size of small suitcases. The Apollo boiler. Great. You could stick it on the wall. And it worked for a couple of years. And they wanted to send this massive big thing that took 2 men to lift it to get it in. Big Valiant boiler. I remember it clearly now. Never
took two Scottish men, but one English man would have done it.
And then we go from the boilers to combis, right? So transition between gas, central heating
story
boilers.
water to instantaneous water.
Yeah, and combis and taking cylinders out. And I'm now on my fourth conversion system. It's gone from combis to heat pumps now.
So we've been in transition all the time, really.
They're continually moving.
Well, arguably, I mean, the first sort of heat pump system that went into this country was in Scotland in 1928. But so that's been going in before we had that. But your transition, so when the transition started in 66, 67, so Canvey Island was the test bed. So that's near where Grandad lived. He was. Yeah. He knew all the people that were in Watson House development that, and then it was I think it was the East Midlands was the first regional gas board to then sort of transition. You guys were the last, because that's because you had the big ceremony in 76. So Dennis went up to Scotland 1st September 76.
Right.
It did this big ceremony and basically said, we've now finished. But as you're saying, there was still bits and pieces to do even into the into the 80s, because you started in 73, so you were in full swing of the transition back then, weren't you?
That's right. So we're still sitting exams, and I was sitting exams as a gas fitter, not as a gas engineer, as gas fitter. Apprentice gas fitter. We were changing over, and we were going to remote areas that had Towns Gas in it, and we were supplying the Towns Gas by containers to keep them going until we got down to conversion. So our job in conversion was to change the meters, to put governors on meters.
Was the gas the same calorific value? So,
No, it's
So,
about twice.
did you have any issues with pipe sizing then?
Methane's
you're
about
getting more,
twice. About
Yeah,
was
twice.
it better?
better calorific value. So it wasn't pipe sizing that bothered us.
Yeah.
It was
Which will end up being a barrier to hydrogen because it's all the way now.
it's the same thing with we had it also all the gas that was used in going to a house was all 1.25-inch iron pipe. So there was no any problem getting gas into it. There was no governors on meters then. We had to change and put governors on, so we've got higher pressure with natural gas.
When did the gas safety laws come in? 79.
Yeah, they
So
did.
you were there was no real real laws when you started. The Wild West when you started.
It's cowboy company. There was laws because we had to still do the same
It was
thing.
1979 that came in the gas safety law.
We started putting more detail down because we had a bigger problem with natural gas could combust quicker between 4 and 40. It would volume in air.
A percentage.
It could blow up. Town's gas was had got a higher percentage of gas in air before it would combust, but natural gas was 4 to 40.
So when you went from town's gas to natural gas, you started getting more explosions.
More explosions, and we went more safety.
Is this just your work, or was it just in general?
Just my work.
Just your work.
I made a lot of numbers for that one anyway.
So you were on the meter converters, because obviously there was cookers, there was the burner sets that people were converting the cookers. So I think there was up to 8,000 models, nearly 8,000 models that needed converting with these burner kits, conversion kits, and I think there was something like, in the end there was 4,000 conversion kits that were developed at Watson House to be able to do this. So obviously you had teams that were doing the boilers, teams that were doing the cookers, you had teams that were just doing specialist burners for the industrial equipment that was all over the country, you know, different bits and pieces, and then you were doing the meters, were you?
Yeah, we were doing meters pre-conversion, so you could still put a town's gas and you put a governor on it. It was okay. So we were doing pre-conversion, and we're also doing safety checks on gas fires. Nobody had a back plate on the gas fires in the days. We had to fit back plates on it. So you got loads of gas fires that you had to fit a closure plate, as we called them, and tape it on and make sure that it had an area underneath it. There was fires that you could get a custom-made closure plate, and there was fires you made one yourself on it. You cut out the hole at the back of the fire. A lot of these fires were fitted, just pushed back to the wall.
So they done that for what reason? Because the combustion was different on it.
Well, if it didn't combust properly, you had a higher risk of gas poisoning. So natural gas, if they tried to run a fire with town's gas injectors with natural gas, it would burn yellow.
Oh, so no burning rate at all.
So no burning rate. So fires,
you need to burn. You need to burn about twice as much as air with That's why the burner kits had to be developed and shown. And there's loads of interesting work. I mean, like I say, my grandfather, who was a combustion engineer, he then started specialising and all went to Sweden, but he knew some of the people working at Canvey Island. He knew the people. He's got a great story about Canvey Island. He died in 2016, bless him, and he won't mind me. So he always used to say he knew some of the consultants that worked on the Canvey Island test bed. So basically Canvey Island was where the first methane ship docked, and they decided, well, that's where we have the test bed, that's where we'll convert all homes to methane first, natural gas, to see how it works, basically. And some of the consultants basically said, yeah, we don't know what pipe work it needs to run through. We think it needs thick wall copper pipe, 4-inch diameter. So they laid basically 4-inch diameter thick wall copper pipe up to people's homes. And what was happening was, because back in the day, I mean, you'll remember this, Duncan, Barry and I, but people would make a cup of tea by putting the kettle on the actual gas cooker, turning the flame on. And, you know, you didn't have electric kettles back in them days, and that's how you made your cup of tea. And what was happening was people were turning that cooker on in the morning and the flames were hitting the ceiling. Because what was happening is, because the pipe work was so large going up to the house, all the different, it's mainly methane, but there are other different gases, and the lighter gases were stratifying to the top.
Settling.
So they were coming through first through the burner jet and literally hitting in the ceiling. So big meeting, consultants got together. Oh yeah, we don't think we need that bigger pipe work. We don't think it needs to be copper either. And all that copper across the whole of Canvey Island got dug up. And my granddad said, that made some people millionaires overnight.
Was he talking about himself in a third person?
He wasn't involved in it, and he was a very honest man. But the way he said it, it sounded like it was done on purpose, because this was a big, big, big thing that was going to be happening in the country. And people like to make money if they can see people are trying to make money now.
Do you think it was a bit fraudulent? They put it in knowing it would have to come back out.
Yeah, I think so.
Wow,
I think so. It's the same with this transition.
How come I don't come up with ideas like that?
It's the same with this transition. I meet a lot of startups that are listening to my podcast to sort of fast track their market analysis, and then when they get hold of me, just to have a chat. Lovely, lovely, lovely people. The majority of them are lovely people, but I do meet some. And all right, I don't know for a fact, but I do meet someone. I think you're just in this to make a lot of money very, very quickly. You can give us stuff about the engineer or the consumer or climate change. You realise this is a sector where you can get in if you're clever, and they're clever. I meet a lot of clever people. They're way clever than me when it sort of comes to business. They're in it for the money. And it's the same with any sort of thing like this. The people that were sort of involved in that sort of test bed obviously realised, crikey, we could get away with a little. It wasn't the whole of the sort of consultancy team involved in it, but I think a couple. But we're going off topic there. I was going to say Scotland's got this fantastic history of gas again, because Murdoch was the first person in the world to light up his house with gas back in 1790 or something, wasn't it?
Right, that's right. Yeah,
Murdoch was the chief engineer for Bolton and Watt, for the Watt engine, if anyone didn't know that. But yeah, a lot of history.
Yeah, there's a museum that's about 20 miles away from here. When you're up, we'll take you there. Murdoch's Museum down in Peebles.
Yeah, I'd love to go.
That's where he riveted the lid of the kettle and put coal in it.
Yeah.
Riveted the top of it, put it on a fire and lit the flame from it. And that's where original coal gas came from.
And you've also got James, what was Greenock, wasn't he? He was near you guys, Glasgow area, wasn't he?
Yeah, and obviously we had Kelvin as well. We know him.
He'll just correct you on this. Watch.
Well, he was Irish
in Glasgow University.
He was
at Glasgow. He was born in Belfast, but yeah,
he was born in Belfast. That's great. But he was a chair at Glasgow University where he did his work on and the degrees Kelvin.
He also had a brother that was. I mean, not a lot of people talk about his brother. I think his brother's name was James Thompson, but he was very involved. They would have these big discussions about. Obviously, it was thermodynamics. He might have even been the person that come up with the word thermodynamics. It was all really interesting history. You got you guys up in Scotland. Apart from good whiskey, you've got sort of a good heritage around. Do you see the MVHR? Getting back to MVHR, Duncan. Do you see? I mean, obviously, we've got the same problems like we've just discussed with sort of heat pumps. It's all about how you put it in, how it's designed, how it's installed. Obviously, there might be a training issue. Are people getting trained properly to do it? I mean, arguably, I would say, if you have a heat pump system put in that's not working very well, you've got that pain of like it's cost you a lot and it's not working well. But with the MVHR, I think there's more of a health issue. I think people are living in homes with this stuff, not realising.
Is there any governing bodies? So what happens if you put MVHR in wrong?
There's nothing.
There's nobody coming around checking them. There's nobody saying. There's no kind of.
No, there's not. In England, you're supposed to be qualified to install it and maintain it. You have to have Part F. You have to have a certificate saying that you're competent to do the job. In Scotland, we don't have that, but we've had people installing them that don't know what they're doing. They haven't really cared anything about it. The consequences are not immediate, but as it goes on, they're not working properly. The consequences can be dire on them. And we're looking at houses that, Nathan, you'd be shocked if you've seen some of the ceilings that I have to see, or pictures of internally when we look at it.
I guess with a heat pump, in the first winter, in the first cold snap, it's not working. But the MVHR, it could be 2-3 years before someone notices, and that contractor's gone, disappeared.
That's right. We know that. We've just accepted it, and we can do something to repair it, replace it, repair it. But when we replace it, we have to replace ducting because the mold grows right the way through the ducting.
And that's quite disruptive to replace.
Yeah. Well, it's okay in a lot of the places where we can get to the ducting. If the ducting's in an attic, which a lot of it is, and it's laid across the attic and it's not insulated, any condensation in the air has condensated into water vapour, or water, and it's now lying in a puddle. So the first summer comes, and spores get through by blowing it through it, the land, and they start to grow. And it can be the whole lot. My guys will say the same thing. We can take out 40 metres of pipework or ductwork and replace it all because it's mold. We cut a section at a time out and look at it. We shine the torch up, put the camera up it, right, still got mold, take a picture of it, show the local authority. That's what your tenant's living in.
They'll be petrified of that.
Absolutely petrified of it. Absolutely petrified.
Does any of the sophisticated stuff sort of have UV systems? I mean, I know sort of my cousin sort of works with sort of the more commercially type things, sort of like things like thermal wheels, which are basically the same thing. You know, they're exchanging heat.
Yeah.
But I mean, during COVID, I know a lot of the clients were very interested in sort of UV systems to kill bacteria and stuff like that. I mean, don't doubt they're in domestic though, are they? Things like that?
No, we're not. We're not even going to go there. The only way we can see it clear, we won't put a drill up with a mop on the end of it, because all we're going to do is move that mold somewhere else and give it a chance to grow somewhere else. We're very clear when we do it that we won't touch it. We won't expect anybody else to. We'll cut it out. We'll cut it out, bag it, skip it. Right, we do that. We take the units out, they go straight in the skip. We put a new unit in and we commission it properly. We give them a commissioning certificate to tell them exactly what this unit's doing.
They got one last time.
They didn't get one last time because nobody filled them in. Because we asked for, have you got a commissioning certificate? No, I don't have one. Well, you really should have had one.
They're not caring. No.
They're not caring. So it is a continual battle. But there's a lot of good guys out there. And there's a lot of good equipment out there. Right? There's some really well-worked stuff coming out in the marketplace from the continent, which can detect body odor and increase the ventilation when they sense body odor, or when somebody sprays antiperspirant, they can sense that through the system and they can up the range and up the fan because they're smelling something that's unhealthy.
Is that VOC then?
VOCs, yeah. So we have them we can independently put it into each room with a sensor on it for smoking, for air quality, for CFCs, for VOCs. There is some really good equipment coming.
Have you fitted much of it? Is it working well? Because does it get a point where you're throwing too much tech at basically opening a window?
I think if somebody's bought a new house and they've done it and they've made it an envelope and it's sealed, we should be looking at stuff like that for them. You should be telling them that that's what they're going. We're not doing that in local authorities or housing associations. What we're doing is providing a method to keep the dampness down. Right? We can put fans on walls, but what we're doing is throwing heat away.
Are you working in the private sector as well as social housing?
Yeah. So there's a lot of people have they bought houses that have been in the marketplace, like the Commonwealth Games site. So we do a bit of work in there. We do. Right. Yeah. They're the people that get it service, Nathan. They're the ones that do care for it.
That homeowner.
They're the homeowner who's, we're talking about a replacement, like for like replacement, without any ducting going, costing £2,500 to £3,000.
See, but ironically, you'd think it'd be the other way around. So obviously, a homeowner comes into a home, and as we know, they don't always get their gas boiler serviced. I mean, most homeowners will get their oil boiler serviced, a bit of a different thing, but a lot of them don't get their gas boiler serviced. Now, social housing should be set up. They've got a facilities manager, they've got a maintenance team, they've got maintenance crews. They should have a maintenance works program that says, well, you got to do this every 6 months, you've got to do this every year, we've got to do this every. So you'd think that's the sector which is actually getting it right, but it sounds like they don't.
Well, some of them do, Nathan. We'll preach to them, and we've got great relationships with them. We'll go and sort problems out of them. Passive vent issues, it's not been installed properly. We'll go and we'll correct the mistakes somebody else has made, and we'll talk to them about it. We'll discuss the best way to go forward on it. Other ones, it's not until it breaks down that we get to go at it. And when it breaks down, it's too late.
Yeah.
It's too late. We'll go in and take a picture and say, we need to change this.
Do you get involved in training at all, Duncan?
I don't actually. No. Yeah, it's something that there's not a lot of training in Scotland on ventilation, right? Because it's not required.
Doing it.
I know. I've got two guys on upgraded training at Paul's heat recovery just now. They're on a 3-day course with them.
Is that a European company or a Scottish company?
It's a Scottish company, but in a very good company.
They're excellent.
Passive Vent and disciples. They talk nothing but passive vents on it.
So it's a passive vent.
So passive vent, or passive house. Sorry, passive house. They say they talk about them, and they've got excellent systems. They are service agents for the top European manufacturers, and they've got a good stock of equipment, and then they've got good guys in there. So they're leading the way in Scotland. We're just picking up some of the bits and pieces. That
Leah's coming up for training. Leah Robson from Your Energy Your Waste coming to Scotland to train.
Great. Yeah.
So, Paul.
Yeah.
Good outfit. Good outfit. They're only across the water, across the Forth. If I was to send my guys on a college MVHR course, I don't think it'd be worthwhile.
It's like a 1 day or a 2 day.
Yeah, you can get that certificate by attending.
Some of my listeners are from social housing, Duncan, and I can see them think, "Oh, I wish Duncan did a little an event where he just explained what it is to us and what we need to look out for and what we should
not
be."
Not an installer one from the other side of it.
I've been asked. One of Scotland's East Coast Housing Associations are having a meeting regarding their new build programme, and one of their key managers phoned me up the other day and said, "Would you like to come along?" I said, "Love to." He says, "Come along and speak to the engineers that we've got. We're going to go through a program. You've got to say why we should be putting MVHR in." I says, "To me, that's a no-brainer for you guys. You're at build time. Get it put it in. Quality guys, get it installed, get the right equipment in, and get it serviced every year. And that will last you 10, 15 years without any problem."
That's a great way to drum business up. So you definitely need this, and give me a phone.
I'm not bothered. If I get one housing association on board, they all talk to each other.
When do you take the chair of Snippeth? Is that coming up soon? Is it?
It comes up in June the 6th. So keep that date in your diary.
Oh right, I'll be nice and warm. That'd be good.
No, you're thinking something else. I think it's Spain. You're saying it wrong.
They come up. We've got an excellent venue, historic venue.
Where are you having it?
Riddler's Court in Edinburgh.
Are you going to all be wearing your regalia, all these chains you wear? Because it's an old. How old is Snippeth? How long's it been going?
You're 100 years. Come on, you had a whole.
Of course, it is. For anyone that doesn't know,
the associations are 140, 160. Dundee, what's Dundee? 160, 140.
140, I think Dundee.
For my listeners, Snippeth is the Scottish and Northern Ireland Plumbing Federation, and I'm a big supporter of them. And Fiona is the CEO, isn't she? And
yeah, she's done a great job.
Give my regards to Fiona when you next see her. She's been on the podcast with Barry. He's been on so many podcasts. So we might boot him out. We might boot him out, Duncan, and I have you instead now.
always willing to do
I'm skating on thin ice anyway. I keep using other people's podcasts.
Well, guys, it's been great. It's been great speaking to you. We're still obviously in sort of silly season winter up in Scotland, aren't we, Barry? How's the heat pump game going for you at the moment?
Yeah, busy. We've got a couple of new engineers. I'm pretty delighted with that. So we're starting to step up again. Yeah.
Mm-hmm. Well, you take care, lads. Always a pleasure. And I'll see you soon.
Thank you very much, Nathan.
You're welcome.